students. Today we are going to discuss about flowchart and pseudocode. The objective of this lecture is we are going to have a recap of the previous lecture, which was on problem solving strategies in algorithm. We'll be studying about flowchart, role of flowchart in problem solving, and role of algorithm in problems. Now, in the previous class, what we had, you had already studied about the what problem solving strategies is all about. What is algorithm? You have while studying algorithm, you have studied about the definition of algorithm, characteristics of algorithm, certain prerequisite that you are supposed to follow while writing algorithm, and at the end you had understood algorithm by having a demonstration of writing algorithm example. Now, what is flowchart? It is nothing but a tool developed in the computer industry for showing the steps that involved in a process is used for solving a computation problem. It is a diagram made up of boxes, diamonds, and other shapes connected by arrows, and each shape represents a step in the process that we have defined for. The arrow shows the order in which the steps are, the instructions are being. Flowcharting combines symbols and flow lines to show figuratively the operations of an algorithm. Now, although there are multiple symbols used for designing flowcharting, but most commonly used symbols are terminal, process, input output, decision, connector, and predefined process. Now, these are some commonly used symbols like the symbol rectangle symbols is used for process. It indicates the type of internal operations inside the processor or memory. Trapezium is used for input output operations. So, in algorithm, wherever we have input output operations, we are going to use trapeziums. Now, this diamond shape very essential, which shows, which demonstrates decision making. Wherever we'll have a statement instructions which denotes decision making, having output either true or false, yes or no, we are going to have dimension. Now, this is oval shape is used for connector. This rectangle having this bar is used for predefined processes. This symbol having a rounded terminal, or this terminal symbol like start and end, and arrows are used showing the flow of instructions sequence of execution. For example, here this we are trying to show you a flow chart for a particular computation problem. Like the computational problem that we have used is compute average of three. For computing average of three numbers, as you have already studied algorithm, and in the algorithm, first and last statement is start statement. So here, in terms of flowchart, the start and stop are considered as terminal statements. So that's why I studied in the previous one. We are using terminal symbol for noting start and end. The next one is for computing average of three numbers. You require in three input user. So therefore, we need instruction that is input instructions. And as you have studied as you have got to know in the previous slide, for internal symbol or input symbol trapezium. So this is trapezium having three inputs in num1, num. Then we need a computation process. So as you have studied in the previous slide, for process we used this rectangle. So we rectangle for average, and finally output, that is again part of input output of trapezium. I think this clears your thing of the various symbols. Now, this is an example which is very basic without having a repetition of the next example that we have used show you people how the repetition of operations is demonstrated in flowchart or denoted. Now here for that we have taken an example like for a given value limit. The limit is a value which will be given by the taken from rather. For a given value limit, what is the smallest positive integer number for which the sum is equal to 1 plus 2 plus up to number? Means we are going to have a sum in incremental basis till achieve number. And here limit will be the greater limit will be Li limit. So how it is going to be done is that we are going to do it through flowchart. So therefore, as you had studied in the previous examples also, first symbol and the last symbol terminal is begin and stop and whatever you want to use. The second one is for a given value limit. It means that the limit value has to be taken from the user, because depending on the limit, the sum will be repeated. Sum of be increased or decreased. So therefore, this taking this limit value from the user, we need a input output instructions, the operation. That's why we are using the input symbol. Now once we take the limit value, then we are doing operation. So two processes. One is we are taking a number value is equal to 0, and another we are taking some value which is equal to 0. So here we are using two assignment statement, means we are assigning 0 to number and we are assigning 0 to sum. So this is the process. So therefore two processes we are using, and after that we are going to repeat certain operations. So therefore we are writing two operations. Two means how long we are going to repeat this operation. So after that we are taking a decision, because now we need to, because already we are initializing sum to 0, need to keep on repeating some operation to till we get sum is greater than limit. So therefore we are taking a decision instruction, we are writing a decision instruction sum, whether sum is the limit. So whether sum is greater than limit, this instruction is going to give either true or false answer. So this is the decision answer, and based on that true or false answer, our execution, the step that we are going to execute will vary. Therefore, first we are writing box where we are writing greater than limit. If it is true, then we are going to directly display number value and the sum value. But if it is false, if sum is not greater than limit, then what we are going to do, we are going to increment the number value by 1. So we are going to write here number is equal to number plus 1. Number we are initializing to 0, so now number will be 1 in the first iteration. Then what we are doing, we are adding sum which was initially 0, sum is equal to sum plus number. And then we are going to again repeat the same operation. We are again checking whether sum is greater than limit by the user. So if it is sum is not greater than limit, again we are going to the operations repeatedly. So this is going to be repeated as long as sum is not greater. And the moment sum becomes greater than limit, we are going to display the output. Clear? So this way, the result of this particular computation problems, 1 plus 2 up to the number we produced. Now, what is pseudocode? Is pseudocode already we have mentioned in the previous class while discussing algorithm. The algorithm is pseudocode. Now, pseudocode is a combination of programming language as well as natural language, which is used for which is used as a method for writing algorithm, is independent of any specific. It is, you can consider it an intermediate step towards the development. It allows the programmer to formulate their thoughts on the organization or on the sequence of computer algorithms without the need actually following the syntax. Now, while writing a pseudocode, we should know what are the symbols that we use for arithmetic operations, the keyword that we can use. So the symbols that is used for arithmetic operations are plus, minus, multiplication. Symbolic names are used to indicate quantities. Keywords that can be used are like print, write, and read. And we also use indentation to indicate branches. Like for example, although we had studied in the previous class regarding algorithm, here we are showing for writing an algorithm pseudocode that we have used. Example, right, computing code. So as you have seen in the flowchart also, we have terminating statement here also. Step 1 start and end. And if you recall previous class also, we have studied algorithm as a sequence of finite unambiguous steps. So therefore, it is unambiguous. We have here finite steps and all are in sequence. Always essential, compulsory to write down steps number. First one is start, second one is input XYZ, flowchart for this output operation, then compute sum is to express y. All in writing or while designing flowchart. Fourth statement is again compute statement, another process, average 3, then print sum here for fifth and sixth we need symbol. So as you have seen, all are unambiguous. We are not following any syntax of any programming language. We have used a symbol like compute, average, AVG, sum. We have used plus, forming arithmetic operation, addition, division. Similarly, for the other example, also for a given value limit plus positive integer number for which sum is equal to sum 1 plus number. Here also, as you have seen, we have specified the input is limit, we have specified the output, the number and sum, and we have specified the instructions in sequence. Like first enter limit, set number 0, assignment statement, that sum is equal to 0, and then we are repeating the A, B, C instruction under 4. These are going to be repeated until and unless a specific condition. See, we are writing, repeat the following. If sum is greater than limit, terminate the repetition. Otherwise, it is increment the number by 1 and add number to sum and set equal to sum. Sum will be sum. And then after that, we are writing number. And so therefore, if the A part condition is true, then directly it will come to the fifth statement. And if A part is false, then B will be executed. Again, it will go to A. And if we'll check decision condition, B decision symbol will be used here for flowchart. And this is going to be repeated as long as A part is true. A part is false. Sorry. As we have studied in this particular lecture, we have role of flowchart in problem solving, how flowchart can designing strategies, solving a problem. We have also demonstrated flowchart design using examples. We have studied about the role of pseudocode algorithm and have designed studied how algorithm examples. References, take me this particular mail